Now we will discuss simple parallel circuits. In parallel circuits, we see that we have the same voltage across each resistance because all these points are common, and the individual, but the current in each branch is different. Here we have the total current, and there we in R1, R2, R3 we will be having a current I1, I2, I3, and sum of these current will be equal to the current IT here. So since these resistances are connected in parallel, we have to calculate the equivalent resistance, which the formula is 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Another shortcut is that for two resistances we have the formula as R1 into R2 over R1 plus R2. So in order to solve these three resistance problem, we can proceed as we calculate first for the R1 R2 equivalent resistance, and then that equivalent resistance we again make put the formula with R3, that R equivalent multiplied by R3 over R equivalent plus R3. So there we get the total equivalent resistance, and when 9 volt divided by this equivalent resistance, we get the total current here. Another approach would be to calculate the individual current, as we have 9 over 10k to get the current in this branch. Similarly, 9 over 2k we get the current in that branch, and 9 over 1k we get the current in this branch, and when we add up these three currents we get the total current. So here we see that this approach is being utilized. 9 over 10k 0.9 milliamps, similarly IR2 and IR3, and when these all are added we get the total current in the circuit. And this is the formula, standard formula, but I have discussed already the shortcut method. Conductance is defined as 1 over resistance. So its utilization is that if we have parallel resistances more than 2, then we can convert the resistances into conductances and then add them up. So a complex parallel circuit can easily be solved using the conductance strategy, but in that case Ohm's law becomes V is equal to IR becomes V is equal to I over G. So please consider this circuit. In that circuit, if there is a jumper wire, we install a jumper wire in parallel with the resistance. Please note that this jumper wire it becomes parallel with 300 ohm resistance. So from equivalent resistance formula we have 0 multiplied by 300 over 0 plus 300. So the resultant would be 0 ohm. So that resistance gets vanished. So if the jumper wire comes in parallel with any resistance, that resistance effect is diminished and we get a short circuit here. So this is a short basically. So in that circuit we would be having resistance 150 ohm. This 300 ohm is removed from the circuit. Similarly, if the path breaks, suppose that 300 ohm resistance gets damaged, so it will open the path. So in that case, if this resistance gets opened, then the total resistance becomes infinite and the current would become 0 in the circuit.